Welcome to Teolumen Insights, where we reveal the hidden forces that shape the way you live and show you how to use them to create real transformation and supercharge your health, mindset, and daily life. Here are your hosts, Emma Greenwood and Nathan Sinclair.
Believe it or not, what follows is an AI-generated conversation, one designed not to mimic humanity, but to illuminate it.
Imagine shrinking the very atom that makes up water, hydrogen, the simplest element, shrinking it to a size that modern science says is just utterly impossible.
Right. Completely impossible, according to the quantum mechanics.
And now picture this impossible shrinking unleashing a flood of pure, clean energy. Energy that could, well, power our whole world. No pollution, no limits.
Sounds like something straight out of science fiction, doesn't
That
it?
really does. A fantasy, almost.
Welcome to Teolumen Insights. Today we're plunging deep into the enigma of the Hydrino. It's a concept so revolutionary, so audacious, it could genuinely be the dawn of a new age. Or, maybe a massive dead end.
A profound misdirection, yeah. The stakes feel incredibly high.
Get ready, because the story of the Hydrino and the man behind it, Dr. Randell Mills, well, it challenges pretty much everything you thought you knew about energy, about physics, about reality itself.
Our journey, or rather the listener's journey we're tracing here, into this really extraordinary world, started with a summer road trip back in 2004, heading towards a company called Brilliant Light Power. Okay.
But the seed for this fascination, it was planted years before. As a teenager, encountering articles about Randell Mills, he was painted as this renegade genius.
A rebel scientist.
Exactly. Daring to question quantum mechanics, which, is the bedrock of modern physics.
And his big challenge was
The Hydrino. This almost heretical idea that hydrogen, the atom we think we understand best, could exist in a state smaller and with more energy packed into it than its standard ground state.
which quantum mechanics says is the absolute lowest possible energy level, like a basement you can't go below.
Precisely. It's like trying to fit a bowling ball into a tiny dent
Yeah.
that physics insists just isn't there, shouldn't exist.
It's not just curiosity then.
No, it became an obsession, a feeling that the stakes here were just immense,
Yeah.
way beyond typical academic squabbles. This felt different.
So who is Randell Mills, the guy taking on Einstein, Bohr, Heisenberg, the giants?
Well, his background is surprisingly down to earth. Grew up on a Pennsylvania dairy farm in the 50s.
Really?
But even then, apparently, his room was basically a lab. He had this intense scientific curiosity from early on, and practical skills, too. Ran a successful grain business as a teenager.
Wow. Okay.
But then there was a major turning point,
Yeah.
a life-threatening accident. And that seems to have shifted his focus, gave him this burning desire to understand the universe at its absolute deepest level.
And academically?
Exceptional. Top of his chemistry class, got into Harvard Medical School saying explicitly he wanted to invent things. Then he immersed himself in graduate-level physics at MIT.
So a real polymath, chemistry, medicine, physics.
Definitely. And he did invent things before the Hydrino really took over. There was Mirage, a cancer therapy idea using something called the Musbauer effect, even got published in Nature.
Nature. That's major league.
It is. Then Lumides, a drug delivery system inspired by fireflies, apparently, plus other ideas in medical imaging, even brain theory.
But these didn't take off.
They didn't reach the market, no. Each seemed promising, but didn't quite break through. And you have to wonder, did those near misses maybe push him towards something even more radical, something like the Hydrino?
Maybe something with potentially bigger stakes.
Perhaps. Something that, if right, changes everything.
Okay, so to really grasp how big a deal Mills's claims are, we need to touch on what he's challenging, right? Quantum mechanics.
Exactly. QM. For almost 100 years, it's been the explanation for how atoms work. But, early on, classical physics had this huge problem.
The electron spiraling into the nucleus.
That's the one, the radiation catastrophe. Classically, an orbiting electron should radiate energy, lose speed, and boom, spiral into the proton in a fraction of a second. Atoms shouldn't be stable.
Which they clearly are.
Right. So Niels Bohr came along with his model electrons in specific orbits, quantized energy levels, a stable ground state they couldn't fall below. But he couldn't really explain why that ground state was stable.
It just was.
It just was, in his model. Then in the 1920s, you get this explosion. Heisenberg, Schrödinger, Pauli, Dirac, quantum mechanics is born.
And it's different.
Very different. It's just focused from trying to picture the atom to describing what we can observe. Energy comes in packets, quanta. Particles act like waves sometimes. Waves act like particles.
Wave-particle duality.
And Heisenberg's uncertainty principle, you can't know everything about a particle perfectly at the same time. Plus, the act of observing changes the system.
The observer effect. It sounds weird.
It is weird. It replaced the old clockwork deterministic universe with this fuzzy, probabilistic quantum world that defies intuition.
And not everyone was comfortable with it.
Not at all. Einstein famously hated the probabilistic nature, the spooky action at a distance. Schrödinger, too. They felt QM was maybe incomplete, that there had to be a deeper, more tangible reality underneath.
And that's where Mills comes in.
That's exactly where Mills steps in. He says, let's go back to classical physics, but rethink the electron. He offers a visualizable model challenging that whole century of quantum thinking.
Okay, so how does Mills use classical physics to solve that core problem, the stable atom, the non-radiating electron?
He goes right back to Maxwell's equations, the foundation of electromagnetism. But he introduces this really radical picture of the electron.
Not a point particle.
No, definitely not. He was inspired by work from Professor Hermann Haus at MIT, who showed theoretically that certain configurations of accelerating charges don't necessarily radiate energy. Mills takes this and models the electron in a hydrogen atom as an incredibly thin spherical membrane of charge, like a soap bubble, but made of charge, perfectly centered on the proton. He calls it the orbit sphere.
A sphere of charge, and that doesn't radiate.
His argument is no, because the charge is perfectly symmetrical. There's no oscillating dipole moment, which is what normally causes radiation in classical physics. It's stable.
So how does it interact with light, absorb, or emit photons?
When a photon hits it, the orbit sphere can get perturbed, sort of wobble or deform, become slightly flattened, maybe. Then it naturally relaxes back to its perfect spherical ground state. And in doing so, it emits the photon.
But a quantum jump, but explained classically?
Kind of, yeah. Classical mechanism for absorbing and emitting energy packets. And he gets further, he claims, this classical model can calculate the energy levels of atoms, like helium, which has 2 electrons with really high accuracy.
Better than QM.
He claims it's more accurate than the approximations often needed in QM for multi-electron atoms, and without needing those complex QM calculations.
Okay. He also mentioned something called resonant energy transfer.
Right. This is key to the Hydrino idea. It's like tuning forks. You strike one, and another one nearby, if it's tuned to the same frequency, starts vibrating too, right, without touching.
Sympathetic vibration?
Exactly. Mills proposes atoms can do something similar. A hydrogen atom can transfer a specific quantized amount of energy directly to another nearby atom or molecule, a catalyst, if that catalyst is properly tuned to accept that exact energy amount. No photon involved.
And what happens to the hydrogen atom when it loses this energy?
It has to go somewhere. Since it can't just radiate it away classically in his model, and it lost energy resonantly, its orbit sphere shrinks. It collapses down to a smaller, tighter, more stable radius.
Below the normal ground state.
Below the normal quantum ground state. That smaller, lower energy hydrogen atom is the hydrino.
And the energy difference is released.
How? It's transferred to the catalyst, or released as heat, or potentially other forms of energy. And if you could trigger this process using ordinary water as the hydrogen source,
You get vast amounts of energy.
that's the potential energy revolution. But, this is where the skepticism really kicks in hard, because the scientific community has been burned before, especially with
fusion.
exactly the cold fusion debacle of 1989.
Right, that announcement. Pons and Fleischmann. And then the whole thing just collapsed under scrutiny.
It collapsed spectacularly, and it created this deep, deep skepticism, almost an allergy towards any claims of new energy sources, especially anything involving electrolysis or tabletop experiments claiming excess heat.
So when Mills started reporting his results...
In 1991, yeah, he was doing experiments using electrolysis, but with light water, ordinary water, not heavy water like cold fusion, and using specific catalysts. And he reported excess heat, attributing it to hydrino formation.
The setup sounds similar enough to ring alarm bells.
It sounded very similar to the public and many scientists. Even though Mills often reported much higher levels of excess heat than many cold fusion claims, the association stuck.
Guilt by association.
Pretty much.
Yeah.
The media often just lumped him in with the cold fusion fringe and made it incredibly difficult to get serious scientific consideration, regardless of the details of his work.
That some people did look into it. You mentioned Thermocore.
Yes. Thermocore, a company specializing in heat management, did an independent investigation and they reported finding significant persistent excess heat, sometimes up to 3.7 times the energy they put in.
That sounds pretty convincing.
It does, but even they were really cautious in how they presented it publicly. The cold fusion stigma was just that powerful.
Were there others? National labs?
There were investigations, yes. Places like Chalk River in Canada, MIT Lincoln Lab, Idaho National Lab, and some apparently found intriguing results, excess energy, unusual byproducts. But often these findings were kind of shelved, or further work was discouraged.
Why? Just the stigma.
Likely a mix of the stigma, the perceived lack of a clear theoretical basis within standard physics, and maybe institutional inertia. Mills also started talking about creating novel materials, hydrino hydrides, stable inorganic compounds formed with hydrinos, claiming they had revolutionary properties.
So he's claiming new energy and new materials.
Right. He kept pushing for access to national labs to get independent validation, really emphasizing the chemistry involved, trying to distance it from physics controversies. But he faced a lot of resistance.
And vocal critics.
Oh, yes. Figures like Robert Park, a physicist known for his skepticism, publicly labeled Mills's work voodoo science, often without really engaging deeply with the experimental data or the theory itself. And when Nobel laureates make dismissive off-the-cuff remarks, that carries a lot of weight too, solidifying that negative perception.
It sounds like an uphill battle, putting it mildly.
A very steep one. Fighting against perceived association, established theory, and prominent critics.
So Mills wasn't just focused on hydrogen atoms, he also applied his classical ideas to the free electron itself.
That's right. He wanted to understand the electron, the fundamental charge carrier, in classical terms too. He looked at how current would flow on the surface of his electron shell model and figured it needed a uniform charge distribution.
Which led him to
modeling the free electron, not as a sphere, but as an incredibly thin spinning disk of charge.
a disk, like a tiny spinning plate.
Exactly. Held together by a balance between the outward centrifugal force from the spin and the inward pull of its own magnetic field, created by that spin.
Okay, that's a different picture.
It is. And it has some really mind-bending consequences, like the apparent radius of this disk, according to his model, actually changes depending on how fast it's moving relative to you. It's a relativistic effect.
The faster it moves, the bigger, smaller.
Thinner and brighter in your frame of reference, according to the calculations. He even used this idea of a flexible, deformable disk to propose a classical explanation for quantum tunneling.
Tunneling, where particles go through barriers they shouldn't have enough energy to overcome.
Yeah. He suggested his electron disk could literally squeeze or deform momentarily to get through potential energy barriers that would stop a classical point particle cold.
Wild. Was there any way to test this weird electron disk idea?
Unexpectedly, yes. An opportunity came up in the bizarre world of superfluid helium. Helium cooled to near absolute zero becomes this quantum fluid with zero viscosity. And if you put electrons into superfluid helium, they get trapped inside tiny cavities like bubbles. Electron bubbles.
Okay.
Experiments were done measuring the drag on these bubbles as they moved through the superfluid, which allowed scientists to figure out their size. And they found something strange.
What was that?
Some of the electron bubbles moved faster and seemed smaller than the standard theory predicted. They called them anomalous ions. It was a mystery.
And Mills had an explanation.
He did. He proposed that these anomalous ions were bubbles, where the trapped electron had absorbed some energy from the helium and reconfigured itself into one of these smaller, stable, fractional excited states predicted by his disk model.
Like different sizes of his electron disk.
Essentially, yes. And remarkably, when he calculated the predicted sizes based on his theory, they closely matched the experimentally measured sizes of these anomalous ions.
That sounds significant. A prediction matched by experiment?
It was certainly intriguing, offering potential support for his unconventional electron model from a very unexpected area of physics.
Okay, so moving from electrons in helium back to energy generation. Mills wanted faster reactions, right? Beyond electrolysis.
Right. He wanted to speed up hydrino formation. So he moved towards gas phase reactions and eventually plasma. He worked with a physicist, John Phillips.
What do they do?
Their early gas work involved passing hydrogen gas over a hot filament, like in an old light bulb, but coated with specific catalysts. And again, they reported excess energy being generated.
Hotter than it should be, based on the input power.
Exactly. But the real action seemed to be in plasma.
Plasma. Superheated, ionized gas.
Yeah, like in a star or lightning or fluorescent light. It's a highly reactive environment. Mills figured it would be perfect for rapidly catalyzing hydrogen into hydrinos because everything's broken down and buzzing with energy.
Did it work?
They reported strong results. And interestingly, they also tackled a puzzle in plasma physics itself, the mystery of hot hydrogen.
Hot hydrogen.
Yeah. For years, physicists had seen hydrogen atoms in certain plasmas moving much faster, having much higher kinetic energy than expected. The standard explanation involved acceleration by electric fields.
But Mills and Phillips had a different idea.
They argued and showed experimentally, they claimed, that this hot hydrogen was actually a direct byproduct of the catalytic process forming hydrinos. The energy released during the hydrino transition was kicking out these high-velocity hydrogen atoms.
So hydrino formation explained the hot hydrogen mystery.
That was their claim.
Correct.
Debunking the old field acceleration model. And the unique light signatures from these hydrinoplasmas also suggested potential new technologies.
Like what?
Super efficient lighting, maybe even new types of lasers like blue lasers. They even demonstrated a small, low-power light source using a strontium-hydrogen plasma.
But getting this published, still difficult.
Still very difficult. The Mills Association that challenged a dogma, it remained a major hurdle, even with experimental results.
Okay, but the energy potential in plasma, that led to something even more ambitious, right? Rockets.
Oh, yeah. If you can release that much energy density from hydrogen, the idea of using it for rocket propulsion is almost inevitable. This was championed by Anthony Marchese, an aerospace engineer at Rowan University.
What was the potential?
Marchese looked at the tyranny of the rocket equation. Basically, the faster you want your exhaust to go, higher specific impulse, or ISP, the exponentially more fuel you need, to the biggest constraint on space travel.
Right, you need fuel to carry the fuel.
Exactly. Marchese calculated that if you could reliably convert hydrogen to a specific hydrino state, H13, using helium as a catalyst in a plasma engine, you could theoretically achieve an ISP of over 21,000 seconds.
How does that compare to normal rockets?
Chemical rockets are maybe 450 seconds. The best ion engines might reach a few thousand, but with very low thrust. 21,000 is game-changing. He calculated it could potentially get a spacecraft to Mars in just 40 days.
40 days to Mars? That's incredible.
It's the kind of leap needed for serious interplanetary travel. And this wasn't just back-of-the-envelope stuff. It actually got funded by NASA.
NASA funded Hydrino research.
They awarded a NASA Innovative Advanced Concepts NIAC grant for the Hydrino rocket engine to Marchese and his colleagues, including Peter Janssen and Buck Schmazel, Phase I funding.
What did they build?
They designed and built prototype thrusters based on plasma cells developed at Brilliant Light Power, Mills's company, hollow cathode plasma cells. And the initial results looked promising. But measuring the exhaust velocity directly proved very challenging. You need sophisticated diagnostics. And ultimately, they didn't get Phase II NIAC funding to continue the work.
Why not? Too controversial. Too difficult.
Probably a combination. Frontier science is always hard, funding is competitive, and unconventional approaches face extra scrutiny. So the plasma era showed huge potential, enormous energy release. But acceptance, still elusive.
But Mills wasn't just focused on energy or rockets. You mentioned he had grander vision, like understanding all of matter.
Exactly. His ambition went way beyond just finding a new energy source. He aimed to build a complete classical understanding of atoms and molecules, essentially challenging the entire field of quantum chemistry.
Using his orbit sphere model.
Yes. This became clearer during that 2004 period when the listener we're tracking was more involved at Brilliant Light Power, focusing on the theoretical side. Mills had worked out this detailed model for helium.
The second element, 2 protons, 2 electrons.
Right. He proposed its 2 electrons, which are spin-paired, actually share a single orbit sphere around the nucleus.
One shell for both electrons.
Yeah. And this model, he argued, naturally explained why helium is so small and so chemically inert and non-reactive. And crucially, his calculations for its ionization energy, how much energy it takes to pull off one electron, were apparently very, very accurate compared to experimental values. And he claimed better than typical QM approximations.
And he extended this beyond helium.
Oh, yes. He developed models for atoms up through neon, the first 20 elements. He envisioned these multi-electron orbit spheres having complex structures, variations in charge density, described by mathematical functions called spherical harmonics.
Spherical harmonics come up in QM too, right? Describing electron orbitals.
They do. But in QM, they describe probability distributions where you're likely to find the electron. In Mills's model, they describe the actual physical shape and charge distribution of the orbit sphere itself. a tangible structure.
And he claimed a high accuracy for all these.
He claimed pinpoint accuracy in calculating ionization energies for those first 20 elements, using just his classical model and fundamental constants. He even made a physical scaled model of the periodic table based on his calculated atomic sizes.
What about molecules? How atoms bond together?
He tackled that too, again, classically. Take the simplest molecule, H0, 2 hydrogen atoms. He modeled it as 2 protons with their outer electron orbit spheres merging together, forming a kind of prolate spheroid shape, like an American football.
2 atoms sharing 1 electron shell.
Essentially, yes. And just by calculating the classical forces, electrostatic attraction and repulsion within this merged structure, he claimed he could accurately predict the bond length, the binding energy holding it together, and even its vibrational frequency.
And this extended to more complex molecules.
That was the idea. Shared orbit spheres, classical force balances. It led him to start a separate company, Millsian Inc., specifically to develop molecular modeling software based entirely on these classical principles. No quantum mechanics involved.
What could the software do?
It claimed to predict the 3D geometry of molecules, their stable shapes, and maybe most importantly, the precise distribution of electric charge across the molecule. That charge distribution is absolutely key to understanding chemical reactivity, how drugs bind to targets, things like that.
And he claimed it worked.
He claimed it was incredibly accurate, validated against the known properties of over 800 different molecules, and could even predict properties for molecules where experimental data wasn't available. He essentially claimed to have developed a complete classical theory of chemical structure.
Wow. So witnessing this must have felt like seeing a whole new science being built.
Absolutely. A vision where all the complexity of chemistry emerges from relatively simple, visualizable classical rules, a potentially simpler, more elegant universe hiding beneath the mathematics of quantum mechanics.
But, as always, dependent on experimental proof and getting other scientists to agree.
Precisely. Theoretical elegance is nice, but it doesn't overturn a century of established science on its own. You need undeniable, rock-solid experimental evidence.
Which brings us back to the experimental side. Around 2005, you said some new people got involved, looking for objective truth.
Yes. People from outside the usual energy tech circles. Kurt Davies, who was then with Greenpeace, and 2 academics from the University of North Carolina, Rick Maas and Randy Booker.
And they got access to BLP.
Apparently, yes. Unusual access. Freedom to really oversee experiments. Rick Maas, in particular, became quite a vocal supporter afterwards. He publicly endorsed the evidence for Hydrinos and said he saw net energy gains maybe 20 to 40%.
That's a significant endorsement from an academic.
It was. Tragically, Rick Maas died unexpectedly not long after, cutting his involvement short. Randy Booker continued consulting with BLP for a while. He reportedly found Mills's atomic calculations extremely good, but like others, he faced disbelief from peers who were just steeped in quantum thinking. They couldn't accept the premise.
Was there any official evaluation around this time?
Yes, the European Space Agency, ESA, did an evaluation in 2005 led by Andreas Rathke, and his conclusion was negative.
Negative, why?
He argued there were mathematical inconsistencies in Mills's theory. But Mills's supporters countered that Rathke was essentially trying to fit a square peg in a round hole, applying quantum mechanical frameworks and assumptions to a fundamentally classical theory, leading to apparent contradictions that weren't really there if you accepted Mills's classical premises.
So a fundamental disagreement on the rules of the game.
Exactly. Later, another physicist, Jan Knotts, argued Rathke's critique wasn't even complete within its own framework and didn't fully explore if Hydrino-like states could exist even from unconventional quantum viewpoints.
It really sounds like a classic paradigm clash.
It fits Thomas Kuhn's description perfectly. An established paradigm, quantum mechanics, resisting a revolutionary new idea that challenges its core assumptions. It's also sometimes called the Semmelweis effect.
After the doctor who advocated hand-washing.
Yeah, Ignaz Semmelweis. His ideas saved lives, but were rejected by the medical establishment for years because they didn't fit existing theories of disease. Mills's supporters definitely see him as a modern Semmelweis, battling entrenched quantum beliefs.
So, faced with this resistance, what did Mills do next experimentally?
He moved towards simpler, more robust chemistry. Generation 2 chemistry, he called it. Basically solid fuel mixtures. You just heat them up, heat and serve, and they supposedly react to form hydrinos and release energy.
Easier to test independently.
That was the idea. And Peter Jansen's lab at Rowan University became a key independent test bed for these solid fuels around 2008-2009.
Jansen, the guy from the rocket project.
The same one. His team at Rowan ran extensive tests on these solid fuels, and they published their findings.
What did they find?
They reported significant excess heat, consistently, up to 6.5 times the energy input in some experiments, and they stated clearly that this couldn't be explained by any known conventional chemical reactions.
6.5 times, that's huge. Any other evidence besides heat?
Yes, and this was potentially very important. They used NMR spectroscopy, nuclear magnetic resonance on the reaction products, and they reported detecting a specific signal that perfectly matched the signature Mills had predicted for a hydrino hydride anion, specifically H14.
Direct molecular evidence.
That's what they claimed. Direct detection of the predicted hydrino state. Janssen even publicly invited other labs to replicate their work, emphasizing how simple the setup was.
Did anyone take him up on it?
Not really, or at least not publicly in a way that gained traction. And then the funding issue came up again.
BLP funded Rowan's research.
Yes, to the tune of about $650,000. And critics immediately seized on that, questioning the independence of Janssen's findings, despite his invitations for replication. It muddied the waters again.
Always something. What came after the solid fuels?
Well, in late 2010, BLP made another announcement. A different type of plasma experiment, a pinch discharge, producing very specific, unique light signatures in the extreme ultraviolet EUV range. They claimed this was a potential smoking gun.
Another smoking gun.
Yeah. This led to more controversy, though. They rented time and equipment at the Harvard-Smithsonian Center for Astrophysics to run some experiments and gather data. BLP then strongly implied this constituted validation by Harvard-Smithsonian.
Which it wasn't.
No. The center quickly clarified they hadn't validated anything, just rented out equipment. And the researcher involved there, Alexander Beekanoff, later expressed reservations about how BLP interpreted the data they collected.
So more PR issues and questions about interpretation.
Exactly. It felt like, despite new data, independent work like Janssen's, the combination of funding questions, past associations, PR missteps, and that fundamental paradigm clash meant the mainstream scientific community was still largely dismissing or just ignoring Mills. Something much bigger, much more undeniable, seemed necessary.
Undeniable power.
Yes.
Which leads us to 2014.
January 2014. Brilliant Light Power drops a bombshell announcement. Millions of watts of power generated, instantly.
Millions of watts.
From what? 2 weeks later, they held a public demonstration. And the setup looked almost laughably simple. A tiny pellet.
What was in it?
Just water, some titanium powder, and a tiny bit of aluminum foil. They placed this pellet on the electrodes of a standard industrial spot welder.
Okay, and then?
They hit the switch on the welder.
Yep.
There was this incredibly sharp sear rick and an instantaneous, blindingly brilliant flash of white light. The entire pellet just vaporized into incandescent gas in a microsecond.
Wow. Just gone.
Gone. Vaporized. Mills's explanation for this breakthrough was that the intense arc plasma from the spot welder did two things simultaneously. First, it instantly vaporized the water into HRO molecules. Second, he theorized these HO molecules themselves acted as both the hydrogen source and the catalyst needed for the Hydrino reaction. This created a runaway chain reaction, an incredibly rapid, self-sustaining cascade of Hydrino formation.
A Hydrino explosion, basically.
Essentially, yes.
Yeah.
He also argued the intense electric field of the arc helped by sweeping away excess charge that might otherwise quench the reaction.
And the power. Millions of watts seems huge from a tiny pellet.
The power density was staggering, thousands of times greater than gasoline. They measured the light spectrum, and it was this broad continuum radiation indicating temperatures like the surface of the sun around 5,000 degrees Celsius.
Sun-like temperatures in a spot welder arc.
Yes. Nick Glumac, a materials science professor who acted as an independent validator for some demos, called it incredibly extraordinary.
And Mills saw this as definitive proof.
He declared it irrefutable proof against quantum theory. He argued there was simply no way known chemistry could produce that kind of energy, that kind of explosion, from that tiny amount of simple material. It had to be the Hydrino.
Okay, so you have these incredibly powerful micro-explosions. How do you harness that? You can't just keep spot welding pellets.
Right. That was the next huge engineering challenge. Early ideas involved things like welding pellets onto a moving metal strip that passed through electrodes, or trying to continuously feed a powder or slurry fuel mix.
Did those work?
They ran into problems, mainly with the electrodes getting destroyed very quickly by the intense heat and plasma. Electrode erosion.
Makes sense. So what was the solution?
This was apparently Mills's big insight, the key to making it practical. Instead of trying to capture the energy as heat, which is hard to handle at those temperatures, capture it directly as light.
Using solar cells.
Exactly. Use photovoltaic cells, solar panels, to convert that incredibly intense flash of light directly into electricity. This was the birth of the SunCell concept.
And solar cell technology was improving rapidly anyway.
Right, a bit of serendipity there. The technology needed to capture the light was advancing independently, so they started designing conceptual power plants, basically. A central reactor chamber surrounded by arrays of high-efficiency solar cells.
Still sounds challenging. What were the hurdles?
Several big ones. First, the light from the reaction was very rich in extreme ultraviolet, EUV, and soft X-rays. Standard solar cells aren't great at converting those wavelengths efficiently. Second, you still needed a way to continuously feed the fuel and regenerate the reactants. And third, you still had the electrode problem, how to make electrical contact reliably without everything melting.
How did they solve the electrode issue?
This was apparently a major breakthrough, the Ghostbusters moment, as someone described it. Liquid metal electrodes.
Liquid metal, like mercury.
They tried molten silver first, then gallium, and eventually settled on molten tin. They developed systems to inject two intersecting streams of this molten metal into the reaction chamber. Where the streams crossed, they formed a continuously regenerating electrical contact point for the plasma discharge.
Clever. A self-healing electrode.
Exactly. Prototypes using this liquid metal injection were built. Then came another refinement, the carbon sphere reactor.
What was that?
Instead of directly hitting the solar cells with the raw plasma light, they had the plasma reaction happen inside a hollow graphite sphere. The sphere would heat up to maybe 3,000 Kelvin, white hot, and then re-radiate that energy much more smoothly as visible and near-infrared light.
Light that standard solar cells can handle efficiently.
Especially concentrator photovoltaics, CPVs, which are designed for intense light. They collaborated with companies like Columbia Technologies and Massimo Semiconductor on developing these CPV systems. Observers like John DiCarlo witnessed impressive power densities from these setups.
Okay, so progress. What came next?
The thermal cell, around 2019-2021. This went back to capturing heat, but in a more controlled way. Molten gallium injectors inside an opaque cell, submerged in water. The goal was continuous steam generation for turbines.
Did it run continuously?
They reported long-duration runs, up to 100 hours, maintaining temperatures around 500 degrees Celsius. They said these were ready for pilot deployments.
And the most recent development? The light bulb SunCell.
Yes, 2022-2023. This seems to be the current focus. A transparent reaction chamber, again using the molten tin streams. It produces this brilliant, stable, white light, very close to the spectrum of the sun, that shines directly onto surrounding solar cells.
Like a self-powered light bulb lighting up solar panels around it.
Kind of, yeah. And they've incorporated clever optics like mirrors for light recycling. They claim this could potentially boost the efficiency of standard silicon solar cells up to an incredible 84% conversion efficiency for the light produced inside.
84%, that's way beyond normal solar efficiency.
It is, because the light source is right there and they can optimize capturing nearly all of it. The videos BLP has released of this transparent SunCell in operation are visually stunning. It really looks like a tiny contained sun.
It sounds like maybe the engineering hurdles are actually being overcome. The dawn of the SunCell.
It certainly looks that way from their demonstrations, which forces us to ask, if this is real, what does a world powered by water actually look like?
Right, a world where fossil fuels are obsolete. What does that future entail? Let's start with the fuel itself.
Okay, the energy density. Gasoline gives you about 46 megajoules per kilogram. Liquid hydrogen, which is already great, is about 120 mJ kilogram.
And Hydrino, from water.
Theoretically, converting the hydrogen in water down to the H14 Hydrino state could release around 2,450 megajoules per kilogram.
Wait, 2,400?
Yep, roughly 50 times the energy density of gasoline. Think about it. A single liter of ordinary water could theoretically power a car for thousands of kilometers.
That's hard to even comprehend. What about cost?
Okay, power plant costs. Building a new natural gas plant might cost around $2,000 per kilowatt of capacity. The electricity cost maybe 10 cents per kilowatt hour, roughly.
And SunCell projections?
BLP project's capital costs around $100 per kilowatt, 20 times cheaper to build. And electricity costs potentially around 0.2 cents per kilowatt hour. That's 50 times cheaper than natural gas power.
50 times cheaper energy. The economic impact alone.
It would transform everything. Transportation first, maybe? Cars, trucks, ships. Suddenly range anxiety is gone. Fuel costs are negligible.
Aviation. Could you fly planes on water?
Potentially, yes.
Yeah.
Cheaper, cleaner flights. Maybe it even makes things like personal flying cars, eVTOL practical. Even hypersonic flight becomes conceivable if you have that much power from a lightweight fuel source.
And the biggest impact, climate change.
This offers a direct route to eliminating carbon emissions. Completely.
Yeah.
BLP talks about a goal of global decarbonization within 20 years if SunCells could be deployed aggressively.
20 years? Is that even possible?
It's ambitious, requires massive scale-up, but the potential is there to replace fossil fuels entirely.
What about the developing world? Places without reliable grids now.
This could be revolutionary. Cheap, decentralized power for remote villages without needing massive infrastructure investment. Imagine cheap desalination providing clean drinking water to arid regions, an end to indoor air pollution from burning wood or dung for cooking.
It sounds utopian, geopolitically.
An earthquake. Countries whose economies depend entirely on oil and gas exports face an existential crisis. The entire global power balance shifts. Energy becomes democratized, available potentially anywhere there's water.
And the planet itself.
Yeah.
Less mining, drilling, fracking.
Huge relief for ecosystems. Maybe restoring rivers dammed for hydropower, halting deforestation driven by the need for fuel wood. It allows nature to heal.
You mentioned back-of-the-envelope calculations for replacing everything.
Yeah, if you look at global energy demand for electricity in vehicles and assume the projected SunCell costs and efficiencies, the numbers suggest that achieving full decarbonization in something like 20 years isn't physically impossible if manufacturing could be scaled incredibly fast. It's a question of industrial capacity and political will, assuming the tech works as claimed.
Okay, so the potential impact on Earth is staggering. But Mills's ideas go even further out, right, to the cosmos. He thinks hydrinos are dark matter.
Yeah, that's another huge piece of his theoretical framework. He believes hydrinos aren't just an energy source, they're a fundamental, unseen component of the universe itself. The missing mass.
Dark matter, the stuff astronomers say makes up most of the universe's mass, but we can't see.
Exactly. The mystery goes back to Fritz Zwicky in the 1930s, noticing galaxies and clusters moving too fast. Their visible matter didn't have enough gravity to hold them together. Then Vera Rubin's work in the 70s on galaxy rotation curves.
Stars orbiting way too fast out in the galactic suburbs.
Right. Flat rotation curves, suggesting there's this huge halo of invisible mass providing extra gravity. Current estimates are that dark matter outweighs normal, visible matter by maybe 5 or 6 to 1. It's the dominant stuff.
And we still don't know what it is.
We don't. Searches for matchos massive, compact halo objects like brown dwarfs or black holes haven't found nearly enough. The leading particle candidates are WIMPs, weakly interacting massive particles, but decades of searching with sensitive detectors have turned up nothing definitive.
There's also MOND, modified Newtonian dynamics.
Yeah, Mondi tries to explain it by changing the law of gravity itself on large scales, rather than invoking new matter. But MOND has its own problems fitting all the observations, and recent hints that dark matter might be more mixed with normal matter than previously thought make simple, wimpy models trickier.
So Mills says it's hydrinos.
He proposes the simplest solution. Dark matter is just hydrogen that is transitioned into these lower energy, non-radiating hydrino states.
Why would that fit the bill?
Well, first, the source is abundant hydrogen is everywhere. Second, hydrinos, being in these tightly bound states, wouldn't easily absorb or emit light, making them invisible or dark. Third, collectively, if enough hydrogen converted, they would provide the extra mass, the extra gravity needed.
But if they're invisible, how could we ever detect them? How could we know?
Mills suggests we might see the byproducts of hydrino formation or interactions, energetic signatures. He points to unexplained emissions from space. Certain extreme ultraviolet EUV light signatures observed from nebulae or interstellar gas that happen to match the energies predicted for transitions between different hydrino states.
Coincidence? Or evidence?
That's the question. He also highlights a mysterious X-ray line seen from galaxy clusters and other objects at an energy of 3.57 keV. He proposes this could be generated by a specific catalytic reaction involving hydrinos.
Okay. Anything else?
Perhaps the most striking claim is about the diffuse interstellar bands, or DIBs. These are hundreds of unexplained absorption lines seen in the light from distant stars. They've been a mystery for a century.
Nobody knows what causes them.
Lots of candidates proposed, none fit perfectly. Mills claims that the calculated absorption spectra of simple hydrino molecules like H14 two hydrino atoms bonded together, match the wavelengths of over 380 of these DIBs with high precision.
If true, that would solve a major astronomical mystery.
It would be huge. So the grand vision here is a universe filled with this hidden sea of hydrinos, providing the gravitational scaffolding for galaxies, explaining dark matter, and potentially solving other puzzles like the DIBs. Dark matter isn't exotic, it's just hydrogen in disguise.
And his cosmic ideas extend to stars, too, even our own sun. He challenges the standard fusion model.
He does. The standard model, where the sun is powered by nuclear fusion in its core, works really well overall. But it had this big historical problem, the solar neutrino problem.
Not enough neutrinos were being detected.
Exactly. Ray Davis Jr.'s pioneering experiments consistently found only about 1/3 of the neutrinos predicted by the standard fusion model.
And the mainstream solution was?
Neutrino oscillations. The idea that neutrinos have a tiny mass and can change flavor, electron, muon, tau on their way from the sun to Earth. So Davis was only detecting the electron neutrinos. This became the accepted explanation, led to a Nobel Prize.
But Mills has a different take.
Completely different. He says neutrinos are massless, they don't oscillate. The reason we only detect 1/3 of the expected fusion neutrinos is because fusion only accounts for about 40% of the sun's total energy output.
Only 40%. Where does the rest come from?
Hydrino formation, according to Mills. He suggests the other 60% of the sun's power comes from hydrogen transitioning to hydrino states deep within the sun, a process that wouldn't produce any neutrinos.
That would neatly explain the missing neutrinos without needing them to oscillate.
It would. He also tackles another solar puzzle, the coronal heating problem.
Why the sun's outer atmosphere, the corona, is millions of degrees hotter than its visible surface.
Right. It's counterintuitive. Standard models struggle to explain exactly how that energy gets transported outwards and deposited in the corona so effectively.
Mills's explanation.
He proposes that hydrino formation isn't just happening deep inside, but also locally, right in the photosphere, the surface, and the corona itself. These localized hydrino reactions release bursts of high-energy EUV and soft X-ray photons.
Which then heat the corona.
Exactly. These high-energy photons get absorbed by the sparse coronal plasma, ionizing it and heating it to those extreme temperatures. He suggests these localized hydrino microexplosions could also be the driving force behind things like coronal loops, solar flares, CMEs, and maybe even the tiny, brief brightenings called solar sparkles seen by high-resolution telescopes.
So, hydrinos powering the corona and solar activity.
That's the idea, and he extends it beyond the sun. He points to white dwarf stars.
Dead stars, the remnants of stars like our sun.
Yes. Their EUV spectra often show sharp cutoffs at specific energies. And these cutoff energies, Mills claims, precisely match the energy required to ionize hydrogen from the H12, H13, and H14 hydrino states.
Suggesting white dwarfs are full of hydrinos, and maybe still powered by them.
It suggests hydrinos are present, and maybe their formation is contributing to the energy output of white dwarfs in their late stages.
Okay, this is already pretty radical. Does it get even more extreme?
Oh, yes. His most radical idea about stars involves what might happen in the very deepest hydrino states. He speculates that when the electron gets incredibly close to the proton in these states, it might actually destabilize the proton itself.
Destabilize the proton, make it decay.
Possibly. He suggests it could lead to proton decay, releasing positrons, antimatter electrons. And he proposes this could be the source of the mysterious 511 kV gamma ray signal seen coming from the center of our Milky Way galaxy.
That signal is thought to be from positron-electron annihilation.
Yes, and Mills offers a potential source for those positrons originating from deep hydrino states. So his picture of the sun is this dual-engine reactor, part fusion, part hydrino. It's a fundamental rewrite of solar physics, all stemming from his classical atomic model.
Okay, let's shift gears back to the really fundamental quantum weirdness, the double slit experiment. Feynman said it contains the only mystery. How does Mills explain that classically?
Right, the absolute icon of quantum mystery. Fire particles, one by one, they build up an interference pattern like waves.
The standard view. Each particle goes through both slits somehow, interferes with itself, and only becomes particle-like when you measure it. Wave-particle duality.
Exactly. Copenhagen interpretation embraces this uncertainty. The wave function is just probability. Measurement collapses it.
Which Einstein hated. Spooky action at a distance, the EPR paradox.
Right, which led to Bell's theorem, a way to test if reality is local and real, if particles have definite properties before measurement and influences don't travel faster than light.
And Aspect's experiments violated Bell's inequalities.
They did, leading most physicists to abandon local realism. Either things aren't definite before measurement, or there's faster-than-light influence, or both. It's a deep puzzle.
So Mills's classical explanation, no wave-particle duality.
He offers a completely different picture. He argues photons aren't point particles but have spatial extent. When a photon hits the double-slit barrier, it interacts with the entire barrier structure. It gets absorbed and then re-emitted.
Re-emitted with a pattern.
Yes, with a pattern determined by the geometry of the whole grating, like how a complex radio antenna array shapes its beam. The interference pattern arises from how the barrier re-radiates the energy, not from the particle going through both slits. He argues the photon itself travels in a straight line from source to detector.
Is there any evidence for photons traveling straight lines?
He points to weak measurement experiments, like those by Steinberg's group, which suggest photons follow trajectories that look quite classical, not spreading out like waves.
Okay, what about Bell's theorem and aspects results? The non-locality.
Mills argues Bell's theorem itself relies on the assumption of point-like particles with local hidden variables. His model uses extended, structured entities, the orbit sphere electron, his photon model. He claims these structured particles interact classically and locally with the measurement devices, like polarizers.
And this classical interaction produces the same weird correlations.
He claims it reproduces the exact same statistical correlations that quantum mechanics predicts and aspect observed, but without needing any spooky non-locality or wave function collapse. It's all classical physics of extended objects interacting locally.
So, for Mills, the whole quantum quagmire is basically a misunderstanding, a result of using the wrong model.
That's essentially his position, that by abandoning visualizable, classical models for abstract math, physics lost its way. His theory, he claims, brings back that intuitive classical understanding.
We're getting into seriously deep territory now. A grand unified theory of classical physics. GTCP, what does that even mean?
It means aiming for the ultimate prize in physics. A single, coherent framework that explains everything, all the fundamental particles, all the forces, including gravity, the origin of mass, using only classical principles.
Wow. Okay. How does he approach something like mass? We usually think of the Higgs field now.
Right. The standard model uses the Higgs field to give particles mass. But Mills goes back to older ideas, like mass being related to electromagnetic self-energy, but adapts them. He points to the top quark discovery in 1995.
It was surprisingly heavy.
Incredibly heavy. And the standard model couldn't predict its mass from scratch. Mills claims he did predict its mass accurately, using an equation from his GUTCP based only on fundamental constants like the speed of light and Planck's constant before it was measured.
A prediction of a fundamental particle mass from pure theory.
That's the claim. His view links mass directly to energy via E-MCSR, but also to the structure of the particle. Remember his dynamic electron membrane. He proposes there's a critical minimum radius related to the fine structure constant,
A smallest possible size.
set by the speed of light limit on internal currents within the particle structure. At this radius, he claims, 4 fundamental classical energies all converge: electrostatic, magnetostatic, kinetic energy of internal motion, and the energy associated with space-time curvature.
Space-time energy, like gravity.
Yes. He proposes that when a particle-antiparticle pair is created from a photon, pair production, the photon's energy, mc_, transforms into the structured membrane of the particles at this critical size, h. Mass is defined at birth by this convergence of energies.
And gravity is linked to this creation.
He suggests that space-time itself contracts radially around these newly formed particles. The energy needed to warp space-time this way is the energy that manifests as mass. It leads to a new conservation law in his theory: conservation of space-time. Space-time can be bent or warped locally, but the total amount is constant.
This sounds like it connects quantum scales with gravity.
That's the goal of any unified theory. His math involves imaginary time, similar to what appears in black hole physics. And in this picture, the Higgs boson isn't needed to give mass.
So what are the Higgs, the W, the Z bosons then?
He views them not as fundamental, but as high-energy, short-lived resonant states of other known particles, like excited states of electrons or protons. Mass rises fundamentally at creation from energy convergence and gravitational self-interaction.
Any other predictions from this GUTCP?
He predicts a hypothetical fourth family of incredibly massive particles, Planck mass particles, derived from the space-time metric energy. But they can't form freely because they'd instantly become black holes.
Speaking of black holes, singularities, does he get rid of those?
Yes. He argues that the minimum particle size, h, and conservation of angular momentum prevent collapse to an infinite point. Instead, when matter gets crushed to a critical Planck density, it annihilates.
Annihilates into what?
Into enormous bursts of pure energy, Planck mass energy photons. He proposes this is the actual mechanism behind gamma-ray bursts, GRBs, the most powerful explosions in the universe.
So GRBs are black holes evaporating classically.
Or preventing final collapse by annihilating. He even suggested the LIGO gravitational wave detection that coincided with a GRB might be the signal of space-time snapping back after such an event. His GUTCP also aims to explain inertia within this framework.
It's incredibly ambitious, deriving everything from classical electrodynamics and relativity.
It's the definition of a theory of everything, but a purely classical one.
And this unified theory extends to the whole universe, cosmology. He rejects the Big Bang.
Completely. The standard Big Bang model, singularity, expansion, cooling, structure formation, is the textbook story. Supported by Hubble's law, the cosmic microwave background, CMB, light element abundances.
But it has problems.
It does. The beginning problem, where did the singularity come from? The singularity itself, where physics breaks down, the flatness and horizon problems, which suggest the early universe was strangely uniform, usually solved by invoking cosmic inflation, which is itself speculative. And now the JWST finding super early mature galaxies that seem hard to explain.
So Mills' alternative.
An eternal oscillating universe, no beginning, no end, no singularity. It cycles forever.
What drives the expansion in his model, if not the Big Bang?
Ongoing mass-to-energy conversion in stars, both fusion and his proposed Hydrino formation. He argues this constant energy release literally pushes space-time outwards, causing the expansion.
Wait, he predicted accelerating expansion.
Yes, back in 1995, based on his calculations of total stellar energy output. This was 3 years before it was observationally discovered. The discovery that won the Nobel Prize and led to the idea of dark energy. Mills says dark energy isn't needed. Stellar energy output does the job.
Okay, so the universe expands. Then what?
He envisions a vast cycle. Expansion phase now. Stars burn, create energy. Space-time expands. Maximum expansion. Stars eventually die out. Black holes form, maybe evaporate via GRBs, as he described. Universe becomes vast, cold, empty.
The heat death.
Sort of. But then a turning point. The diffuse background photons eventually undergo pair production, creating matter again, mostly neutrons decaying to hydrogen. Gravity starts to pull everything back together. Contraction phase begins.
A big crunch.
Leading to a rebirth. New hydrogen collapses, forms new stars, new galaxies. The cosmos reignites. But it doesn't crunch to a singularity. It reaches a maximum density and temperature and then bounces. A new expansion phase starts.
How long is a cycle?
He estimates maybe 1 trillion years. Our current 14-billion-year-old universe is just in the early morning of its current expansion cycle.
What about the cosmic microwave background, the CMB? Isn't that proof of the Big Bang's afterglow?
Mills interprets the CMB differently. He sees it as the ambient thermal background radiation of the universe now, the leftover heat from countless previous cycles, not from a single origin event.
And the early galaxies JWST is seeing.
His oscillating model handles that easily. They could be structures left over from a previous cycle or just formed faster in the current cycle than standard models allow.
So an eternal cyclical universe powered by classical physics. No beginning, no end.
That's the vision. A radical departure from standard cosmology.
Okay, we've covered energy, matter, cosmology. Does Mills's theory say anything really wild about gravity manipulation? Flying saucers?
Slight chuckle. Well, we are getting into the most speculative territory here. But yes, his GUTCP does lead to some pretty out there ideas about gravity and propulsion.
Like what? We know inertial mass equals gravitational mass, right? The equivalence principle. Things fall at the same rate.
For neutral matter, yes. Confirmed very precisely. There's still debate about antimatter. Does it fall up or down? Most think down, but it's hard to test.
But Mills has an idea about electrons and gravity.
A really radical one. Remember his free electron as a flat spinning disk. He argues that because of this specific geometry, it has zero intrinsic curvature associated with it, and therefore, it should have zero gravitational mass. It shouldn't fall.
Free electrons don't feel gravity, seriously.
That's the claim. He even suggested this might explain those old, controversial Whitbourne and Fairbank experiments from the 60s that seemed to show electrons falling slower or even slightly accelerating upwards.
Whoa, okay, what else?
He initially theorized about something called pseudo-electrons, electrons that absorb specific energy quanta and warped into a negatively curved shape. He predicted these would be actively repelled by gravity, immensely, a potential fifth force.
The anti-gravity.
Essentially. There were some BLP experiments reported around 2015 showing electron beams scattering upwards through helium gas at certain energies, which he tentatively linked to this. But later in 2023, he revised this, suggesting pseudo-electrons probably only form in extreme gravity near black holes, maybe explaining jets from galactic centers.
So maybe no easy anti-gravity, anything else for propulsion?
Yes, another idea for reactionless thrust, no propellant needed.
The dream of space travel. How?
His model involves a free electron absorbing and then re-emitting a linearly polarized photon. Because of the electron structure and how it interacts with the photon's field, he argues the electron gains a net momentum kick in one direction.
But where does the recoil go? Conservation of momentum.
He argues the recoil is absorbed by the space-time fabric itself, or perhaps the photon source. It's complex, but the bottom line is a claimed net thrust on the electron.
How much thrust?
His calculations suggested about 1 megawatt of power, which could potentially come from a compact Hydrino reactor, could generate enough thrust to hover a craft weighing 500 kilograms.
A megawatt hover car.
That's the implication. Silent, efficient VTOL craft. Continuous acceleration space drives. A true physics-based space drive, not just engineering tricks.
Highly speculative, obviously.
Extremely speculative. But it shows the kind of imaginative, potentially revolutionary places his theory leads, if you follow its logic. It certainly gives you a different perspective, maybe even hints at that physics-powered flying saucer after all.
Which brings us finally to the philosophy of it all. After this incredible journey through Mills's ideas, what does it mean? How do we even decide if something like this is true?
That's the deepest question, isn't it? It forces you to think about what science is. The 20th century, the quantum century, really changed how philosophers thought about science.
How so?
Well, you had movements like the Vienna Circle, logical positivism, the syntactic view. They tried to define science as this perfectly logical language based only on things you can directly observe and measure.
Sounds rigorous.
It was. But it struggled to capture the role of intuition, understanding, the process of discovery, the use of models and analogies, the stuff that scientists actually do.
So what came next?
The semantic view gained ground. It sees theories less as just sets of equations and more as models, conceptual representations of how some part of the world works, defined by core principles. It puts understanding back in the picture.
Okay, but when should we believe one of these models or theories?
The big debate. You have scientific realism on one side. Realists think the goal of science is to find the true story of reality, including the unobservable things like electrons or fields. They believe our best theories are approximately true descriptions. Einstein was basically a realist.
And the other side?
Empiricism, or instrumentalism. They argue the goal is just to find theories that are empirically adequate theories that accurately predict what we observe. Whether the unobservable parts of the theory, like wave functions, are real, is irrelevant, or unknowable. We just use the theory because it works.
Like using a tool without knowing exactly how it's made inside.
Exactly. Bess and Frassen's constructive empiricism is a key version of this. And honestly, that instrumentalist view resonates with how many physicists approach quantum mechanics. It predicts incredibly well, so they use it, without necessarily believing its weirdness reflects deep reality.
And the story of Mills, where does it fit?
The narrative often presented, like in the book detailing his work, casts this whole saga as a battle for scientific realism. It argues Mills's work, if correct, is a vindication of trying to find that deeper, visualizable, classical reality that QM seemed to abandon.
Saying instrumentalism maybe led science down a less productive path.
That's the argument, that focusing only on prediction, treating QM like an effective but opaque black box, maybe stifled the search for deeper understanding. Mills represents that drive for a clear, intuitive, classical picture.
Is there an argument for believing Mills from a realist perspective?
Realists often use the no miracles argument. It basically says the stunning success of our best scientific theories would be a miracle if they weren't at least approximately true descriptions of reality. Applied here, the argument would be, how could Mills's theory possibly work so well across so many different areas, atomic physics, chemistry, cosmology, astrophysics, making accurate predictions, if it wasn't tapping into something fundamentally true about the universe? Its success would be a miracle otherwise.
So the whole Hydrino story isn't just about energy, it's about how we think science should work.
Absolutely. It's a fascinating case study in the philosophy of science. It shows how our beliefs about science, what its goals are, what counts as a good explanation can shape scientific practice, and what ideas get accepted or rejected. Mills, in this light, is a throwback, pushing for classical clarity and a universe that ultimately makes intuitive sense, maybe even a beautiful one.
And so we conclude our deep dive into the extraordinary and controversial world of Randell Mills and the Hydrino enigma. We've traversed a landscape of potentially revolutionary energy generation, a radical reimagining of the atom and the molecule, a direct challenge to the bedrock of quantum orthodoxy, a bold new vision for the sun and the cosmos, and even the tantalizing prospect of manipulating gravity itself.
Is this the dawn of a new era in physics? The long-sought answer to our planet's energy challenges? Or perhaps a meticulously constructed, yet ultimately incorrect, intellectual edifice? The final judgment, as always in science, will rest with the relentless march of time, the outcomes of future rigorous and independent experimentation, and the open minds of generations of scientists yet to come, willing to question established truth and explore even the most audacious of claims.
Thank you for joining us on this mind-bending journey into the Hydrino enigma here on Teolumen Insights. If this exploration has sparked your curiosity, please be sure to like and subscribe for more in-depth dives into the frontiers of knowledge. Until our next exploration, keep looking up, keep asking the big questions, and keep seeking the truth. This is Emma.
And this is Nathan.
For Teolumen Insights, signing off.